Welcome everyone. In this video we will learn about the serial port programming of PIC16F microcontroller. The previous video we have learned about the two types of serial communication standard, that is asynchronous and the asynchronous. In the PIC16F microcontroller, which has UART, that means it has the ability of transmitting the data in the synchronous mode as well as in the asynchronous mode. So the UART is a full duplex protocol, and in the case of asynchronous mode of the PIC16F UART, the two devices will be using the two signals like transmit and the receive, because the transmitter and receivers are running at their own speed. They need not be synchronization between the transmitter and the receiver. But in the case of synchronous mode, along with the transmit and receive signal, the devices should be sharing a clock also. The transmitter will be sending the clock as a separate signal along with the data bits which are to be transferred. In the case of I2C system, which is a serial communication standard, and it is only a synchronous. So here the master and slaves are used for communication, where master will be generating the clock and it will be sending to the one of the slaves, where exactly slave will be receiving the clock and it will address whenever the master is trying to communicate. So both of them are connected between a serial data cable, which is called as a SDA. Since it is a synchronous, there should be a one more signal should be used between these two master and slaves, so that is a serial clock. So the clock can be up to 1 megahertz, and it is completely depending upon the software structures. So the hardware is much simpler and the software is more complex. So if you see the hyperterminal program in the Microsoft Windows, which will give the idea like what are the different speeds we can use it for communicating through a serial standards. So the bits per second is a programmable, which can be from 110, 300, 1200 like that, and the data bits is a 8, and the parity, whether we can have or we can neglect the parity, or the stop bits has to be 1 or 2. So all these are the properties we can see from the hyperterminal. So in order to configure the baud rate in the PIC16F microcontroller, 3 registers have to be used. That means the registers associated with the baud rate generator are TXSTA, RCSTA and the SPBRG. So in this slide we will see about what is TXSTA register. So it is a transmit status and control register. It is a 8-bit register. So in this 8-bit register we are focusing on bit 4 and bit 2 for serial port programming. So bit 4 is a sync bit. So this will decide whether we are choosing the synchronous mode or asynchronous mode for the serial communication. So it is for both the receiver and the transmitter. So sync bit is 1 for synchronous mode and sync bit is 0 for asynchronous mode. So the programming part which we are focusing will be sync 0, because we are focusing only on the asynchronous mode. The bit 2 is depending on bit 4, because if we are choosing asynchronous mode, then we can have the different speeds for the serial communication. So in the case of asynchronous mode, we can choose two speeds, and if the BRGH bit is set as 0, that means it's a low speed communication, and if BRGH bit is set as 1, it is a high speed communication. That means the bit 2 is unused if we are choosing the synchronous mode, which is set by the bit 4. The next register is RCSTA, which is Receive Status and Control Register. This is also 8-bit register, but we are focusing only on the bit 7, so that is a serial port enable bit, SPEN. So this bit will be set as 1 for enabling the serial port, that means to configure the RX and TX pin, that is a port C pins. So if you want to disable the serial port, then this bit has to be set as 0. The third register is the SPBRG. So this register is called as a baud rate generator. So this bit sync can be a 0 or 1 for choosing the synchronous and asynchronous. So in the case of synchronous mode, when the low speed communication is selected by setting BRGH is equal to 0, then the baud rate will be the FOSC divided by 64 into x plus 1, where FOSC is the crystal frequency. And when the BRGH is 1, that is a high speed communication, then the baud rate will be FOSC divided by 16 into x plus 1. In the case of synchronous mode, where we do not have the speed selection, so the baud rate is generated or calculated by using the formula FOSC divided by 4 into x plus 1, where exactly x is nothing but the value which has to be loaded into the SPBRG register. Typically this value is within the 8-bit range, that means 002 FF. So the baud rate is a programmable, that means the user can decide what value should be loaded into the SPBRG register. For asynchronous mode, the baud rate is given by FOSC divided by 64 into x plus 1. And here we can find for the crystal frequency of 10 MHz, the different value has to be loaded into the SPBRG register based on the different baud rate. For example, if you want to choose the baud rate 38400, then the value of x, that nothing but the value which has to be loaded into the SPBRG is 3. So for 19200 it will be 7, and for 9600 it will be F, and so on. So now we will see about the TXREG register. So this is the 8-bit register used for serial communication, and the data which has to be transmitted via the TX pin, it has to be first placed in the TXREG. That means the user has to store the data in the TXREG. So once the data has been placed in the TXREG, it is automatically accessed by a register TSR. This register is non-accessible to the programmer, means it is only for the internal purpose. So this register TSR will convert the data which we have placed into a 10-bit data. So it will be performing the framing action. So it will add the start bit and the stop bit. So we have to notice that the TXREG is accessible for the programmer, but TSR is non-accessible. So it is only for the internal use. The next register is a RCREG. So this is also 8-bit register. So when the bits are received serially via the RX pin, so we have to eliminate the additional bits like start and stop bit. So this is done and the 8-bit of data is placed in the RCREG. So once the data has been received in the RCREG, it has to be stored in the some other file register, because we should be able to receive the next set of data in the RCREG itself. The last register which is used in the serial communication is the PIR1, that means peripheral interrupt register 1. So this has the individual flags which will act like the status of the transmit and receive. There are only 2 bits are used in this, that is a bit 5, that is RCIF, and the bit 4, that is a TXIF. So RCIF is a receives interrupt flag bit and the TXIF is the transmit interrupt flag bit. So RCIF will be 0 when the RCREG is empty. That means the data is not at all collected in the RCREG. So RCIF is 1, that means the complete data bit is received and it is sitting in the RCREG. So the programmer has to transfer the data from the RCREG into any safe place before the next set of data will be received. The TXIF flag will be 0 when the TXREG register is full. That means the data is not at all transmitted or it is under transmit. So TXIF will be 1, that means the register is empty. What is the importance of TXIF flag? So we have understood that the data which we have to transmit, first it has to be placed in the TXREG. So as soon as we place the data in the TXREG, the TXIF is cleared. That means the data is sitting in the TXREG, it is not at all transmitted. So when the entire byte is transmitted via the TX pin, that means 1 bit by bit, the TXIF bit is raised, indicating that the data is completely transmitted and it is ready for the transmission of the next byte. So it is a programmer responsibility to check the TXIF flag before transmitting the new byte. So for example, if he places a data in the TXREG before the previous data is completely transmitted, then some portion of the data will be lost. So these are the references. Thank you.